In this video tutorial, we're going to look at solving logarithmic equations. So similar to other types of equations, when we solve, we're going to do the inverse operation. So if I have x squared, I square root. If I have the third root of x, I cube it. Same with exponentials and logarithms. So we are going to use exponents to cancel out logarithms. So a logarithm equation is an equation with a logarithmic expression that contains a variable. Keep in mind that if the log with a base b of x is equal to the log base b of y, then because they have the same base, x must be equal to y. So if log base b of x equals log base b of y, then x must equal y. So similar to solving an equation with a square root, absolute value, or maybe a quadratic, you must eliminate any addition or subtraction if possible. So whenever you solve those, you had to get rid of that extra addition or subtraction. Same thing here. To help you accomplish this task, you can use inverse operations to move items from one side of the equation to the other, as well as use the properties of logarithms to condense the expression on one side of the equation. So reminders. If I have a log base b of v plus log base b of w, I'm adding exponents, so that means I multiply the values, so I have log base b of vw. If I have log base b of v minus log base b of w, then I am dividing, so I have log base b of v divided by w. And if I have a number times a log, then it's power to a power, so the e, the number in front, is actually the exponent to my value, so I can condense it down to that. We will be using all three. Let's take a look at a few examples. On the first, I have log base 6 of 2x minus 1 equals negative 1. So normally, I don't know what to do with that. But what we do know is if that we have 6 raised to log 6, I know that cancels out. So what you can do, just like you would square root both sides, I'm going to do what they call exponentiation. So 6 raised to the log base 6. And whatever I do to one side, I have to do to the other side of the equal sign. So 6 raised to the log 6, that goes away, and I end up with 2x minus 1 equals, and 6 raised to the negative 1 power is a 1 over 6, because negative 1 flips it over, and then I just solve like normal, so I add 1, 2x equals 1 plus 1, 6 is 1 and 1, 6, divide by 2, x equals, and 6 times 1 is 6 plus 1 is 7 over 6. Division becomes times by the reciprocal, which is 1/2. So I have 7 over 6 times 2, which is 12. Go ahead and try number 2. Pause the video, come back, and look at the answer. In number 2, we have to condense first because we have log base 12 of x plus log base 12 of x plus 1. Can't have addition. We have to condense those down. So if I have addition of logs, that's like adding exponents. So I can condense that down into log base 12. When we add, we multiply, so it's x times x plus 1 equals 1. And then I can say, oh, well, I have one thing on one side, so 12 raised to the log 12, 12 raised to the 1. And then I cancel that out, and I get x times x plus 1 equals, and then 12 to the first power is just 12. Distribute, so I get x squared plus 1 times x is x. And that equals 12, and then subtract 12 from both sides. X squared plus x minus 12 equals 0. Guess what? We get to factor. So what times what makes negative 12? That adds up to positive 1. That would be x plus 4 and x minus 3. So my x values would be negative 4 and positive 3. Now the question is, can I use negative 4 and positive 3? So let's plug in negative 4 for x. So I have log base 12. I plug in negative 4 for x, but I can't have the log of a negative number. By definition, that x, that value right here, there's no way to get a negative value if I have a positive base. So negative 4 doesn't work because it makes it log base 12 of negative 4. Let's try 3. So if log base 12 of 3 plus log base 12 of 3 plus 1 equals 1, so I have log base 12, I plug in 3 for x, plus log base 12, I plug in 3 for x. And then I have log base 3 plus log base 12 of 3 plus 1. 3 plus 1 is 4. And then if I condense those down, it's log base 12 of 3 plus log base 12 of 4. So that's a log base 12 of 3 times 4 is 12. And does that equal 1? Yes, it does. So our only answer in this case is 3. Negative 4 is extraneous. It's an extra solution. So go ahead and pause the video and try number 3 on your own, and then play it back to see the answer. So number 3, we have log base 3 of 8x minus 2 and log base 3 of 5 minus x. Both sides have log base 3. There's no extra addition or subtraction at the end. So we can actually just exponentiate. So if this side is 3 to the log 3 and this side is 3 to the log 3, they're both the same base. So they cancel out on both sides, and I get 8x minus 2 equals 5 minus x. Let's add x to both sides. And I have 9x minus 2 equals 5. Add 2. 9x equals 7 divided by 9. So x equals 7 over 9. And then you can go ahead and check that value to make sure it works out. So go ahead and try number 4, 5, and 6 at home for homework and bring them in on our next day of class.